All right, in objective 2, we're going to be focusing on calculating our gram formula mass for elements and compounds. You'll also commonly see this referred to as molar mass. They mean the same thing for us. So first off, where are we getting gram formula mass from? So when we talk about units that we use for the mass of single atoms, we use something called the atomic mass unit, which is an AMU or U. So what's the mass of a single oxygen atom? So in our periodic table, okay, this mass, 15.9994, is the mass in AMU of a single atom. Okay, that's called the formula mass, which is the mass of an atom or molecule in that AMU unit. But atoms are too small to use as grams of single atoms. So that would be equivalent to this mass in grams. We can't measure that in our own lab. We're working with so many more than single atoms. So it's a lot more appropriate for us to use something called a gram formula mass. So this allows us to work with a large number of atoms that we can actually measure in the lab in grams effectively. So gram formula mass, or GFM, is the mass of what's called 1 mole of an atom, molecule, or compound in grams, which we can measure in our lab. So 1 mole is similar to like 1 dozen. If I have 1 dozen of something, I would have 12, say I have 1 dozen bagels, I would have 12 bagels. Okay, when I have 1 mole of something, I have 6.02 times 10 to the 23rd particles of a substance. This can be atoms of an element, molecules, or a compound. It's a huge number, but 1 mole simplifies down that massive amount of particles. So 1 mole of carbon would mean that we have 6.02 times 10 to the 23rd atoms of carbon. Okay, that many atoms of carbon are simply going to be, when I use my periodic table now, we're now going to just use this number in terms of grams. So 12.011 grams of it. Okay, so this is just right off my periodic table. Okay, this 12.011 grams per mole is the GFM of carbon. Okay, when we go to do it for formulas, or compounds, I should say, we're just going to take their individual GFMs, look at how many we have in a compound, and add them all together. So I'm going to do, again, a couple of these with you, have you do a few on your own. So determine the gram formula mass, the mass of 1 mole of each of these compounds. Okay, so make sure you have your periodic tables ready to go, and how we're going to add these up. So I'm going to be looking at barium chloride. So I have 2 elements here, barium and chloride. So I'm going to first look up their GFMs on the periodic table. Barium is right here, 137.33. And chlorine is 35.453. Okay, so those are just right off, again, the periodic table. Okay, then I'm going to be looking at the number of atoms. So this little spot here is going to be the number of atoms based on the formula. So this is where our objective one's going to come in. So with barium, we have 1 barium atom, and I have 2 chlorine atoms. Or really, these are ions, which we haven't gotten into yet. So I have barium ions and chloride ions. So I'm going to just multiply those together. So this is going to end up being 137.33. I'm going to multiply this by 2, and I get 70.906. And when I get those, I'm just going to take the sum of them, add them together to get 208.236. Okay. At that point, I usually am going to round it to the 100th spot. Okay, so when I look at the GFM of my barium chloride, I'm going to get 208.24 grams per mole. So if I had 1 mole of particles of barium chloride, it would be equivalent to 208.24 grams of it. Okay. All right, let's take a look at another one together. So in this one, I have 3. So I have potassium, carbon, and oxygen. So same thing, I'm going to look up their GFMs off the periodic table. So for potassium, this is 39.0983. Carbon is 12.011, and oxygen is 15.9994. Then I'm going to be looking at their number of atoms based on the formula. I have 2 potassium, 1 carbon, and 3 oxygen. Okay, then I'm going to just simply get the product of each of those. So 78.1966, 12.011, and 47.9982. So then I'm going to take all their individual masses and add them together. So you should get 138.2058. And then the same thing, I'm going to be rounding this to the hundredth spot. That 5 is next to it, so it's going to round this place up. So when I look at the GFM of my potassium carbonate, it's going to be 138.21 grams per every mole of it. All right, so for these next two, I'm going to have you pause the video, try them out, and kind of check, see if you're doing these right, so that way you can do it completely on your own shortly. All right, so let's do C first together. I'm going to write this out a little bit differently instead of setting it up in a chart, so you can kind of see another way that takes up a little bit less room. So I'm going to first work with calcium. So I have 3 calcium atoms, and then I'm going to plug in its gram formula mass. So calcium is 40.08. Okay, and that's just the GFM of calcium. Okay, then I'm going to add it to phosphorus. You have to be careful here. Phosphorus has 2 atoms. So I have 2 phosphoruses, and its GFM, which is 30.97376. Okay, and that's just the GFM of a phosphorus. Okay, then I'm going to add it to the oxygen. And oxygen I have 2 times 4, so I have 8. So I have 8 oxygen, and then its GFM, which is 15.9994. Okay, and then I'm just going to take the whole sum of that, being really careful with the parentheses in my calculator, and you should have gotten a GFM of 310.18 grams per mole. Okay, and actually before that, when I got in my calculator, just so you can see this was 310.18272, and I just rounded it to the hundredths place there. All right, so if you haven't yet, and that one looks good, I want you to pause the video, and I'm going to have you try out this aluminum sulfate compound and see if you can determine the GFM. All right, so what you should have done here is, I'm going to write it the same way as the one above, is I have 2 aluminum, so I'm doing aluminum first, times its GFM, which is 26.98154. Okay, and then I'm going to do sulfur. Sulfur is 1 times 3, so I have 3 sulfur, times its GFM, which is 32.065, plus my last one, oxygen. Oxygen, I actually have 4 times 3, so I have 12 atoms, times its GFM, which is 15.9994. Okay, when I add that all up, I get 342.15143, okay, which then I'm going to round to my hundredth spot, which would be 342.12 grams per mole, and that would be its GFM. All right, so now you're going to do a bunch of practice on your own. Remember, you should have your periodic table and be really taking your time looking at how many atoms of everything you have so that you can set up this expression correctly.